Hello everyone. Today we are going to see the operation of distance relay. This one is the distance relay made by PRDC, and this is the actually distance relay of, demonstration kit. Here the AZM 1114 plus numerical integrated feeder protection relay. It is made by Elin India, and we are going to see how this works. So now we will see what are the calculation and how to fit the settings in relay. Calculation. Let's say this is the transmission line. This is L1, this is L2, this is L3. L1 is of 100 km, L2 is 100 km, L3 is 150 km. There are circuit breakers in sending end and receiving end of the transmission line. The relays are situated in the secondary side of the CT and PT of the circuit breaker. Our relay stays here. So here if the CT ratio is 2000 ampere by 5 ampere, and the PT ratio is 400 kV by 110 volt. So let's say these are zebra conductor. So for zebra conductor, R value is R value is 0.0674 ohm per kilometer, and for zebra conductor X value is 0.28 ohm per kilometer. Hence the Z value is root over of R square plus X square, that is 0.28 square plus 0.0674 square root over, that would be 0.29 ohm per kilometer. And for relay we have to find a relay characteristic angle or RCA angle, that is tan inverse of X by R, that would be tan inverse of 0.28 divided by 0.0674, that would come 86.5 degree. For relay setting, we have to know about the zones of operation of relay. Zone 1, let's say for this relay, zone 1 is up to 80% of the line. Zone 2 is 120% of the connected line, that would be up to this 120%. And zone 3 would be 100% of the line connected line and 100% of the longest line connected to that line, that would be this one and this one, that would be up to this, it would be zone 3, that is 100% plus 100% of the longest line connected to the relay line. Hence for zone 1, R would be 80%, that would be 100 into 0.8, that would be 80 kilometer. for zone 1 x would be 80% of the line, that would be 100 into r would be 80 kilometer into 0.0674 ohm per kilometer, that would come around 5.392 ohm. For zone 1 x would be 80 into 0.28 ohm per kilometer, that would come 22.4 ohm. Like that, for zone 2 distance would be 100 into 120%, that would be 120 kilometer. So r will be 120 into 0.0674, that will come 8.088 ohm. Likewise, x will come 120 into 0.28, that will be 33.6 ohm. For zone 3, 100% of the line, that is 100 kilometer, plus length of the longest line, that would be, in this case it is what, 150 kilometers, so it is plus 150 kilometer, so the total length will come 250 kilometer. So resistance will be 250 into 0.0674, that will be 16.85 ohm, and x will come 250 into 0.28, that is 70 ohm. After that, we have to actually, all the calculation are done for the primary side, and the relays are connected in the set of the CT and PT. So we have to refer the resistance and reactance to secondary. So to convert that to refer them to secondary, we have to multiply CT ratio by PT ratio to the resistance and reactance. That will be 2000 ampere by 5 ampere divided by 400 kilovolt by 110 volt. It will come around 0.11. So R1 dash will become R1, that is 5.392 ohm into 0.11, that will become 0.59. This is referred to secondary for zone 1 resistance. Likewise, x1 dash will come 22.4 ohm into 0.11, that will become 2.464. Likewise, R2 dash will become 8.088 ohm into 0.11, that will become 0.89 ohm, and x2 dash will become 33.6 ohm into 0.11, that will be 3.70 ohm. R3 dash will become 16.85 ohm into 0.11, that will become 1.85 ohm, and x3 dash will become 70 ohm into 0.11, that will 7.7 ohm. We have to consider fault resistance for zone 1, fault resistance for zone 2, and fault resistance for zone 3. We are considering fault resistance for zone 1 as 10 ohm,